Okay, today it's kind of like Inception. I'm doing a video over a video. This may be a first time for me. So anyway, I am talking about a problem that I did with you last time I was with you. And right now we've got the answer down to two things. The answer is pi over 6 in green there and 11 pi over 6. But you got to say plus 2 pi n. But now we're doing it for cosine of 2x. So let's hear me talk a little bit more about this part. Oh, it doesn't seem like it can handle a video inside a video. I'm going to pause for a second and see if I can figure this out. Okay, so I'm going to punt on trying to play the video inside the video. But here's what I want you to do. I want you to write what I say. Ready? Find a blank spot. U equals pi over 6 plus 2 pi n. Got that one? I'll say it one more time. U equals pi over 6 plus 2 pi n. And the other answer, leave yourself some room, the other answer was U equals 11 pi over 6 plus 2 pi n. Now, why are we saying U equals? Because in this problem here, do you see where it says cosine of 2x? That 2x right there, we would replace the 2x with a U, and we would have solved the problem, and it would have come out exactly like the other one. And you would have had those two answers. U equals this, and U equals that. But then you would need to do a substitution back. So now, in for your U, what are you going to put? A 2x. Go ahead and do it and solve it. Let's see if you remember how that part works. Okay, so first you swapped out the U for a 2x because this is like the end of a U substitution where you'd get an answer that says U equals, but then you swap it out for what was substituted in the first place. So it's 2x equals all that. So how do I get x alone? It's simple. Divide by 2 or multiply by a half. So did you already multiply each of these things by 1/2 and then get x equals pi over 12 plus 2's cancel pi n? Raise your hand if you had that right. Okay, good. Then the problem is that is a good answer if they say what are all the solutions. But what would be challenging is if they said, I want all the solutions that are between 0 and 2 pi. Do you remember on the quiz I said you could stop right there and that was good enough? Okay, but to get the rest of the story here before your test on Thursday, you will be expected to limit the answers to between 0 and 2 pi. So do you remember that this was really a placeholder for you can use whole numbers like 1, 2, 3, 4, 5. In fact, you could even use 0 on that. So here's how you're going to get all the solutions that are between 0 and 2 pi. Would you agree that the first thing you could stick in here is 0, and pi times 0 is just 0, and therefore the first of your several answers is pi over 12. Does that make sense? What's the next one? You put in not 0, but what? 1. You stick in a 1, and that means this is 1 pi. So then you got to take pi over 12 plus pi. I'll give you a hint. It's over 1. Find a common denominator, add them together. Try that right now. And then stick in a 2 and find out what that would be. You want the answers that are only the answers that are between 0 and 2 pi. I'll pause for a second. Will you find me as many more answers as you need to get the answers between 0 and 2 pi? I saw too many people stuck, so I'm helping. 12 pi over 12. Can't tell you have a common denominator now? Now I can add the tops. What do you got? 13 pi over 12. Now you got to do the smell test. Does that smell bigger than 2 pi to you? Nope. Therefore, it's one of my answers. Cool. What if I now stick in a 2 here, and I'm adding 2 pi plus this. Do you see something fundamentally wrong with that? Okay, hint. Yes, you got it. What is it? It's going to be bigger than 2 pi because it's 2 pi plus pi over 12. That's bigger than 2 pi. You could go ahead and do it if you want to. It'd be 24 pi over 12 plus 1 pi over 12 makes 25 pi over 12. But if you included it, I'd have to mark you wrong because you included answers that were bigger than 2 pi. Do you get how that's just one piece bigger than it should be? Because 2 pi would have been 24 pi over 12. This is 25 pi over 12. Too big. Throw it out. So this answer works and that answer works. Now you got to admit, I kind of spoon-fed you through that process. I'd like you to find the answers that are between 0 and 2 pi that you would get for this part, considering our u substitution was that u is equal to 2x. Finish that part. See if you can get it. It's going to be 2 or 3 answers. Sometimes there's as many as 6. But in this case, I believe you're going to find 2 or maybe 3 answers that from this equation. Pause while you try it. Go. All right, so here's what you should have done. You should have said u is really 2x because you do a u substitution in that type of problem. And now 2x equals all that. Well, I got to get x alone. I multiply by 1/2. 1/2 here and 1/2 here. And this becomes 11 pi over 12 plus, and the 2's cancel, pi n. That would have been a good answer if they wanted all answers. Okay, now what if they want only the answer between 0 and 2 pi? Well, the first thing you do is stick in a 0 here, and that's really simple. That becomes 0, and it's just 11 pi over 12. So then usually you only have to stick in 1 and maybe 2, but it really does depend on the problem. I'm going to stick in 1 now. That's 1 pi. Would pi plus 11 pi over 12 stay under 2 pi? Yes, it would. So then usually that first one works. Okay, not always. Depends on the problem. Okay, so I'm sticking in a 1, and I got now pi. So it's 11 pi over 12 plus pi, which is the same as 12 pi over 12. Why did I do that? Because now I have a common denominator. I can add the tops, which makes a total of 23 pi over 12. That is so close that I have no reason to even try adding more to it. Therefore, I got those 2 answers, and that's it. Raise your hand if you had those right. Okay, good. Do you see how you could potentially, the problem we just did, actually had 4 answers? It had this answer, and that answer, and the 2 we just did. This answer, and that answer. That was a problem that had 4 answers. There can be as many as 6 answers. I don't believe we would ever do anything more than 6 answers. But yeah, that's just one problem that's got 6 answers. And that is a typical question of an R3 variety. If you can handle that, that's kind of an R3-ish type problem. All right, I want to actually step back in time just a little bit and say, what about these old inverses that we were doing? Do you remember how they had restrictions and they're only allowed in certain places? I hope you're a visual person like I am and can remember that there was one that went from here to here, and the other 2 went from like here to here and there to there, which is pretty much the same thing, but not exactly. Do you remember those? What's the one that's going across the top right here? Yeah, inverse cosine is allowed there. How about these other 2? Well, one of them's what? Sine, and one of them's what? Does it matter which one's which? Yes. This one's tangent because why? It's not touching. It can't work at pi over 2, and don't call this 3 pi over 2, not in inverse world. Negative pi over 2. Awesome. Some of you guys remembered that. That's cool. Then, do you get how nothing exists there? Nothing grows there? That's the dead zone. Don't ever do inverse trig there. And last thought, this spot is rare. Do you get how only one thing would ever be there? Okay, only if you're doing inverse cosine. And the last thing is this spot is negative. That's the negative zone, because you're going to be tempted to get an answer like, oh, I see that the angle is like pi over 6, but you can't say pi over 6. And you can't say 11 pi over 6, but you can say negative pi over 6. That's the negative zone down there. All right, that I hope will help you as you try this red problem that I've put on the board. That would be like an R2. Should be super simple, and once you get your triangle drawn in the right place, you'll have an angle. Because if you remember, these are saying, it's like this is a little guy standing here with a bubble saying, I want angles. I want an angle. And in fact, if it's inverse trig, you're pretty much going to have an angle. Yes, sir. Yes. I'll pause for a second while you figure out this answer. Raise your hand if you're already done, just out of curiosity. All right, only 5 people. I'll wait. For those that are kind of stuck, here's my first step usually. Rewrite this as sine of some angle is -1/2. And I want to clarify, this would have unlimited answers. So it is different. The rewrite of this is not exactly the same thing. But it's like this guy has special restrictions, but other than that, you do it like this. So it really does help to write the rewrite. You just got to remember that you have the restrictions of the inverse. So in this case, inverse sine means you can't be here and you can't be there. I'll let you try to figure it out from there. You should have drawn a triangle here and said opposites 1, hypotenuse is 2, this is square root of 3. That makes that a 30-degree angle, also known as pi/6. Sounding familiar? Okay. So, would there be another answer down here? Would there or not? All right. There's one of these two that works and one of these two that doesn't. Why doesn't this one work that I just said? Yeah, it's supposed to be a -1, and I drew it where there would be a positive. That one's wrong. Okay, so this one's -1, and then the hypotenuse is 2, and that's square root of 3. And now I can't use pi/6, but I can use -pi/6. Raise your hand if you had -pi/6. Okay, awesome. It's because it goes down into this zone, -pi/6. All right, now let's do something similar to that, except it'll be a nested one. Inverse cosine of 1/2, and then I want to do sine of that. I'll pause for a second while you figure that one out. Okay, I was asked a very good question about the last one. I'm gonna reiterate something. Why don't you say plus 2 pi n in these kind? Because they're, yes? Yeah, they can't go everywhere. They can only be between those two things, which is pi/2 and -pi/2. So if you've got the answer that's between -pi/2 and pi/2, that's the only place inverse trig can be. And so you can't keep adding 2 pi's to it. You might end up over here or something where you can't be, or over there where you can't be. And it can't be answers that are bigger than pi/2. So therefore, you're not going to get things that are like pi/2 plus 2 pi. Not okay. So don't add that to an answer like this, because it's inverse trig and it's restricted where it can be. All right, back to the one we were just doing. Did you start on the inside? And did you do a rewrite? I'm curious how many actually wrote cosine of some angle is 1/2. How many have that on your document? All right, I strongly recommend it. Here's why. Because later, what if we were doing secant? Do you remember how you do that? What if this had been secant of theta? Then from here, it's not hard to flip. Remember how you'd flip secant into, say, I don't want to do secant. I want to do cosine. Okay? And then you'd flip the other side and say cosine of theta equals 2/1. That kind of thing. All right, let's go back to, I think it's a good idea here. I'm just going to undo a few times here. I think it's a great idea to rewrite them like this. You just got to remember your limits. The limitations on this thing, the restrictions. That's an inverse cosine. It's only allowed here to here. So that's out and that's out. And this one's positive. Notice there's no negative in there. And therefore it must be in here. And this is cosine is adjacent over hypotenuse. And that makes this a square root of 3. And that makes this a 30. And that makes this a 60. And I know the radians for that, and that's pi over 3. Pi over 3. Am I done? No, but pi over 3 was right for the first part. Raise your hand if you had pi over 3 for the first part. Good. Then it's really just sine of pi over 3. Do you get how it'd be kind of silly to redraw the whole triangle? Because I already have one in the right spot. And I should just use this triangle. Sine's opposite over hypotenuse. Opposite of hypotenuse, root 3 over 2. That's your final answer. Raise your hand if you had root 3 over 2. Okay, good. Then you get inverse trig. You get solving. So what don't you get? Well, the solving kind, that kind where we had like 6 answers or whatever, they can get a little more complicated to set up. So let me show you one. Let's say it was this. Sine squared plus 2 sine plus 1 equals 0. Do you get how that is a quadratic? Anytime you see a quadratic like that, you should be saying to yourself, oh, if I can factor it, I should. Because this can factor. You might want to do a u substitution to make your life a little easier and let u equal what in this case? Sine. So then this becomes u squared plus 2u plus 1 equals 0. That is eminently easy to factor. You get it factored, you get the answers, but the answers say u equals. You be sure that you don't leave a u in your answer. Did you get u plus 1 and u plus 1? And then did you get u plus 1 equals 0, so u equals -1? No sense in doing it twice. The other side's identical. You know, this could do this, but it's going to give you the same answer. So then I can't leave it as a u. I substitute it back in for sine. So sine theta equals -1. And now you've got another one of these problems. Does this have the restrictions of an inverse? Did you ever see an inverse in any part of this problem? Then there's no inverse restrictions. Therefore, did you remember to put plus 2 pi n at the end of your answer? There's no restrictions, so your answer isn't just one thing. It kind of is one thing. Where do you get sine? Oh, I'm going to put another 1 here. That helps me realize this is a weird one. Opposite and hypotenuse. The hypotenuse is the same size as the opposite. That only happens at those quadrantal spots. So it's either here, 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 or here. And as soon as you realize that sine is y, what would cosine have been, by the way? No. What would cosine have been? X. Sine is y, cosine's x, and what's tangent again? Y over x, okay. Sine's y. Where is y -1? Right there. That's the spot where y is -1. So what's the angle that's right there? 3 pi over 2. I get why you might have said -pi over 2, but that would have been if this was inverse trig. Was this an inverse trig question? No, it was not. Okay. Therefore, the answer's 3 pi over 2. Now, could there be more answers than that? Yeah, because this isn't limited by inverse trig rules where you can only be between here and here. So if it says find all, it's kind of a hint. If the problem says find all the solutions, then you say plus 2 pi n. If the problem says find all the solutions between 0 and 2 pi, would there have been any others? In this case, are there any other answers that are in this zone right here? No, there wasn't any other answers in that zone. So this would have been the only answer between 0 and 2 pi. But if they said find all the answers, you'd have to remember to add the plus 2 pi n at the end. Okay. So that's a typical question. And here's an even more complicated one. Do you get that sine squared is the exact same thing as 1 minus cosine squared? Do you get how they could have given you this problem and you would have had the identical answer? It wouldn't have taken that much longer. You just would have had to realize, oh, I can take this and make it into a sine squared, and then I can realize that it's factorable. That's what today's assignment's like. You got to figure out how you can make the thing factorable. So let's do some of it. Let's get to the assignment for today, and it's 15.2. Hopefully you're already there. I'm going to pause while we find the day 2 homework. So why is this different than what we just did? Because you got to do some swaps first. 1 minus sine squared is like cosine squared. What are some other ones you remember? The one with the tan is what you seek. And then how about the one with the coat is cozy? Okay, good. So if I saw cotangent, could you take that other one with the coat thing, and rearrange it? It would be cozy cosecant minus 1. Okay, good. All right. So do you remember cosine of 2x? It's the greedy function. If you can remember it, replace it right here with what it is. If you don't remember it, you'll have to look it up. There's a sheet from last unit that you could go find if you had to. But I hope you have this one memorized. Told you to memorize this one. This one and sine of 2 theta. Remember I said cosine is the greedy function because it always has to be first? It was cosine theta. And then if it has to be first, then it has to matter that it's first, and that means it's a minus. And what am I missing that's really important? Squared. Cosine squared and sine squared equals cosine x. And I get how a lot of kids would just get stumped right there. Wait a minute, I'm going to make this a theta. You can use x's, I'm going to use thetas. Doesn't matter. A lot of kids get stumped right there because they're like, but there's a sine and a cosine and a cosine. If they were all cosines, I could do u substitution. Sorry about that. Or if they were all sines, I could do u substitution. So make them all one or the other. So what are you going to do? What will be smarter? Yes, sir. No, we replaced cosine of 2 theta with this. And this is just recopying that. Thanks for asking. I do make mistakes all the time, so keep checking on me. All right. So which one of these guys has to get replaced? Sine squared. And you replace sine squared with, so I'm going to put it in parentheses so I don't screw up my negatives. 1 minus cosine squared. Remember, I'm doing one of your homework problems here, so I'd suggest following along with me. Not that you wouldn't normally. Then it's cosine squared minus a negative cosine squared, which means plus a cosine squared. Cosine squared plus another cosine squared makes 2 cosine squared. The negative goes on the 1 there, and that's a minus 1. I'm going to put that at the end. I'm going to move this cosine to the other side and make it minus cosine theta equals 0. I did like 3 steps at once there. I hope that wasn't making your brain explode. These two, that and that, added together to make that. The negative is gone, or the sine squared is gone, got replaced with 1 minus cosine. This negative 1 is now right here. And this was a positive cosine over here, but I brought it to the other side of the equation and made it a negative cosine. You could have said I subtracted cosine from both sides. And from there, you should be able to handle making a u substitution and solving. This is the same exact idea. You know what cosine of 2x is, right? I just did it 2 seconds ago. Okay, so you should be able to do that. And you set all of these equal to 0 and you factor them. They'll always look like this when they're done. Okay, but to get it that far, you have to get everything to the left side of the equation first. Do some substitutions so they only have one thing, like cosine, or maybe they only have sine in them. All right, so we're going to do those two. Number 25, you may skip. Number 33 has an interesting twist. Do you have the first part memorized on number 33? What's sine 2 theta? 2 sine cosine. Good. And then equals, better not leave that as tangent. Sine over cosine. I'm going to make it. Now, if you're ever tempted to like, oh, I could divide both sides by sine and get rid of the sine, that's a hint that you're onto one of the kind of problems that can be factored. If you reset this up right, it can be factored. So how do you factor it? You start by setting it equal to 0, get everything to the left side, and then you'll be able to factor it. I would recommend you factor out the sine. Okay, so start by getting this over to the other side, and then factor a sine out of everything. I'm going to pause for a second while you work on that for a minute. Try to get that problem a little further. Okay, there we got everything moved to the left side. Do you get how they both have a sine in them? They both have a cosine in them too. You could actually get rid of the cosine, but it's a little easier to get rid of the sine. So I'm going to factor the sine out. If you can factor it, you should. Why? Because as soon as you have it set up as something times something, then you can set both parts equal to 0. That part is equal to 0, and whatever this part comes out to be will be equal to 0. All right, now, what is left when I take a sine out? I have 2 cosine theta minus, that sine has to be replaced by something. What do I put up there? 1 over cosine. You might be thinking to yourself, why is that any better? Because it's this times this, which means this could equal 0 or that could equal 0. This one's super simple. Sine theta equals 0. Solve. You go, okay, sine's y. Where is y equal to 0? Because you can't make a triangle out of it with a side of 0, right? So it's got to be either here, 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 or here, and you're going to get 1 or 2 answers. You figure that out. Okay? Then I'm done with this part. Because I figure out my answers one of these spots. Or a couple of those spots. Then, this part has to equal 0. 2 cosine theta minus 1 over cosine theta equals 0. I've given you a lot of little rules for a reason. One of them was early on, is to clear fractions. It's one of those top 20 skills. Clear the fraction. What do you do to get rid of that fraction? Multiply by what? Cosine. I multiply everything by cosine. This will become cosine squared, hint, hint, factorable. And this will become cosine cancels cosine, and that just becomes a 1. And this, what's cosine times 0? 0. So it cleans up really nicely to just be something you can simplify. 2 cosine theta squared, 2 cosine squared theta minus 1 equals 0. Solve. Well, you just add 1 to both sides, divide by 2, take a square root. But when you square root a variable, don't forget you have a plus and minus answer. You've hit the big time, boys and girls. You're covering so many little things. You got to remember things like when you square root variables, you get absolute values and therefore 2 answers. All these little things come into play. You just got to be really careful. You're only going to have like 8 questions on your test. And all of those little things that come into play. Yes, sir. All right, but you didn't. Because if you just, what did you say you multiplied by? Okay, so did you get this same equation right here? Okay, but where did your sine go? Okay, if you cancel off your sine, do you get you just lost an answer? Because there was an answer for that? All right, so that was, you're close. But, all right. By the way, you can let, the last question, number 38, that's got the 2 rams on it, that's out. You can skip that one. Have a good day.